Okay, concept number 2 is independent and dependent events. So let's write concept number 2 up at the top so that we know that's what this is. Okay, so before we get started, we're going to fill in some vocabulary so we know what the heck we're talking about when we're doing these examples. So this first one, when the outcome of one event does not affect, gosh, this person does not know how to use English language, does not affect the outcome of a second event, the two events are independent. So this one is independent events. So when one outcome has no effect on another one, they are independent, which makes sense. They can occur without affecting each other, so they're independent of each other. Okay, so the next one, when the outcome of one event does affect or affects the outcome of a second event, the two events are dependent. So this next one is dependent events, when they do have an effect on each other. Okay. When two events cannot happen at the same time, the events are mutually exclusive events. So mutually exclusive events. They absolutely cannot happen at the same time. Okay. If A and B are mutually exclusive events, the probability of both A and B happening is 0. They cannot happen. Okay, it makes sense. So if I have A and B and they're mutually exclusive, there's 0 possibility of both of them happening at the same time, which is what this is saying right here. Okay, so let's get to a couple formulas here. Probability of A and B, provided they are not mutually exclusive, like above. If A and B are independent events, then the probability, I'll put this over here, of A and B happening, if they are independent, is the probability of A times the probability of B. We kind of saw this with rolling 2 coins, or throwing 2 coins and getting a head and then another head. That's 1/2 times 1/2. So those two are independent. Flipping one coin does not have an effect on the other coin. Or flipping a coin once has no effect on if I flip it again. It doesn't matter. Okay? You need to determine whether events A and B are mutually exclusive before you can find the probability of A or B. This is supposed to say A and B, but whatever. Okay, so now this next one is the probability of A or B. We call this an intersection, we call this a union. Okay, so A and B versus A or B. I'm going to give you some notation here. You don't always want to write it like this. You want to write it as this in a different color so that you can see it better. Probability of A and B. So that little symbol right there is like an upside down U, means and. A or B is actually a U. Intersection, union. Okay, so A and B, A or B. Okay, so if A and B are mutually exclusive events, then the probability of A or B happening, using this notation, is simply the probability of A plus the probability of B. Okay. If they are mutually exclusive. So this next one, if they are not mutually exclusive, the probability of A or B is the probability of A plus the probability of B minus the probability of A and B happening. So minus probability of A and B. Remember, that's the and symbol. So I want you to write these down, okay? There's an ad on Spotify, sorry. Okay, so write these down, and then we're going to do some examples together. There are 1, 2, 3, 4, 5, 6, 7 examples. So I will do 3 in the video and then we'll do the other 4 in class. Okay, so I'm going to pause this video. Hopefully you get all the vocabulary down, and I'll see you in the next one over here on example number 1.